Hello. So in this video, I will be writing an efficient program to find the sum of a contiguous subarray within a one-dimensional array of numbers which has the largest sum. So we're looking for the largest sum from a contiguous subarray in this one-dimensional array nums. So the first thing that I'm going to do is declare a new variable called current to keep track of the current sum that we will be iterating through. And current will firstly be defined as the first index in nums. So index 0, which will equal -2, but we'll get to that later. And then we'll define another variable, max, which will also be initialized as the first index in nums, and that will be keeping track of the max sum that we find in the contiguous subarrays. So we'll create a for loop. In this for loop, we will go ahead and set I as equal to 1 since we've already initialized the other variables as 0. I will be less than the length of nums. And I will increment on every loop. So from here, what we're going to do is change the definition of current on every iteration of the loop, and we're going to use the math.max function that exists in JavaScript, which is simply going to compare the current number in the array that we will be looking at to the definition of current, the previous definition of current, plus that current number. So what this will do is give us the greater number between the two to weed out negative numbers and help us find the max. And let me close that parentheses. Next, we will be changing the definition of max on every iteration. We'll also be utilizing the math.max function here, and we'll be comparing current to max. And we can close our for loop. So from here, I'm going to change colors so that we can keep track of everything. So what we're going to be seeing on every iteration is the definition of current changing and the definition of max changing. So on the first iteration, we're going to be looking at nums at the index of 1, which is going to be 1. So currently, current equals -2. So we're going to compare 1 to -2 plus 1, which is -1. In this case, 1 is the greater number, so current will now equal 1. Max is then going to compare current, which is equal to 1, to the previously defined definition of max, which is still -2. So max will then equal 1 as well. Now we're going to loop through again, and at this point we're going to compare nums at index of 2, which is -3. -3 compared to current, which is 1, plus -3 is going to be -2. -2 is greater than -3, so current will now equal -2. Max is then going to compare current, which is -2, to max, which is 1, and 1 is greater, so max will remain at 1. Next, we're going to compare the index at 3, 4. So 4 compared to current, which is -2 plus 4, which is going to be 2. 4 is going to be the greater number, so current will now equal 4. Max will then compare current to max. 4 is greater than 1, so max will now equal 4 as well. Next, we're going to iterate through to -1. Oops. -1 compared to current plus -1, which is 3. The max will be 3. Max will compare current to max. Max is 4, so max will remain 4. Next, we're going to compare with 2. So 2 compared to current, which is 3, plus 2, which is 5, the max will be 5. So current will now be defined as 5. Max will compare current to max, and since current is now greater, it will be updated to 5. Next, we're going to compare with 1. First, we're going to say 1 compared to current, which is 5, plus 1, which is 6. 6 compared to 1, 6 is greater. Current will now equal 6. Max will compare to current. Current is greater. Max will now also equal 6. Next, we'll compare -5 to current, which is 6, plus -5, so 1. Current will now equal 1. Max will then compare max to current. Max being 6 will be greater and will remain 6. And we'll move on in the loop. We'll finally be comparing the last index, which is 4. So 4 compared to current plus 4, current equals 1. So that'll be 4 compared to 5. 5 is greater, so current will now equal 5. Max will compare itself to current, and max is 6, so it is still greater, and it will remain the same. So to finish and get the result of our code, we can just write a console log to print out the result. So console log max. And that is the greatest sum of a contiguous sub. Time for this, which I almost forgot to do, is going to be n squared, since we only went through the loop once. So for one loop, the time complexity